Hello students, let us start with theorem. Let phi be a real valued function. Let phi be a real valued function on the closed and bounded interval AB such that phi dash is continuous on closed interval AB. Okay, let capital A is equals to phi of A and capital B is equals to phi of B. Then if f is continuous on phi of closed interval AB, we have integration from A to B f of x dx is equals to integration from A to B f of phi of x into phi dash of x into dx. Okay, see here students what we have given. Phi be a real valued function on the closed and bounded interval AB such that phi dash is continuous on closed interval AB. We have given capital A is equals to phi of A, B is equals to phi of B. Then if f is continuous on phi of closed interval AB, then we have integration from A to B f of x dx is equals to this A and B are capital, which is equals to integration from A to B f of phi of x into phi dash of x dx. Okay, so let us see proof of this theorem. Proof is here. Suppose f is continuous on phi of closed interval AB. Okay, continuous on phi of closed interval AB. Therefore, f is Riemann integrable on closed interval AB. Here f is continuous on phi of closed interval AB means f is Riemann integrable on phi of closed interval AB. That's why f is Riemann integrable on closed interval AB. Therefore, we have f dash of x is equals to small f of x, because this is by first fundamental theorem of calculus. Okay, x is belongs to phi of closed interval AB. Okay, let g of u, let this is a construction. G of u is equals to capital F of phi of u. Okay, u is belongs to closed interval AB. So take derivative on both sides. We will get here. We will use chain rule. F dash of phi of u into phi dash of u. Okay, this is equals to, here we will replace capital F dash by small f. This is small f of phi of u into phi dash of u. U is belongs to, actually u is belongs to closed interval AB, but here we have, this is by f dash of x is equals to f of x. Okay, now taking integration on both sides, we will get integration from A to B g dash of u into du is equals to integration from A to B f of phi of u into phi dash of u du. Okay, that is integration from a to b f of phi of u into phi dash of u du is equals to integration from a to b g dash of u du. Okay, now simplify this side. This is equals to what? Integration and derivative get cancelled, so here will remain g of u, integration from a to b, integration from a to b. Okay, this is nothing but g of b minus g of a, g of b minus g of a. So here our construction is g of u is equals to f of phi of u. Put here g of b and g of a. So we will get integration from a to b f of phi of u into phi dash of u du is equals to g of u is f of phi of u. So g of b is f of phi of b minus g of a is capital F of phi of a. Okay, phi of b in theorem we have given phi of b is nothing but capital B minus f of phi of a is nothing but capital A. Okay, so we will get f of b minus f of a. Okay, so here this is nothing but integration from a to b f dash of x dx. Okay, which is equals to integration from a to b small f of x dx. We have already written that by first fundamental theorem of calculus, f dash of x is equals to f of x. Okay, therefore we get integration from a to b f of x dx is equals to integration from small a to b f of phi of u into phi dash of u du. Hence proof of theorem is completed. Okay, now we will see mean value theorem. First mean value theorem. First mean value theorem. First mean value theorem is if f is continuous, if f is continuous on closed interval AB, then there exists C belongs to open interval AB such that integration from a to b f of x dx is equal to f of c into b minus a. If f is continuous on closed interval AB, then there exists C belongs to open interval AB such that integration from a to b f of x dx is equals to f of c into b minus a. Proof. Suppose f is continuous on closed interval AB. Therefore, f is Riemann integrable on closed interval AB. Students, always remember that every continuous function is continuous almost everywhere. And we know that f is continuous almost everywhere if and only if f is Riemann integrable on closed interval AB. Okay. Now see here, since f is continuous on closed and bounded interval, closed and bounded interval say capital M and minimum value say small m at some point of closed interval AB such that f of t1 is equals to small m and f of t2 is equals to capital M. Why this is? Because f is continuous, so it attains maximum value and minimum value. Suppose that maximum value is m and minimum value is small m, such that f of t1 is equals to small m and f of t2 is equals to capital M. Okay. Therefore, see here what we will get. F of t1, obviously function is always greater than or equal to minimum value and less than or equal to maximum value. F of t2, that is m is less than or equal to f of x is less than or equal to capital M. Okay. Therefore, integration from a to b m dx is less than or equal to integration from a to b f of x dx is less than or equal to integration from a to b capital M into dx. Okay. Here m is constant, so take it outside of integration, and integration of dx is x. If we put upper limit and lower limit, we will get it b minus c. So integration of this is m into b minus c is less than or equal to integration from a to b f of x dx is less than or equal to m into b minus a. Okay. Divide b minus a throughout these inequalities. We will get m is less than or equal to 1 upon b minus c into integration from a to b f of x dx, which is less than or equal to capital M. Okay. See here, students, since f is continuous on closed interval AB, there exists C belongs to open interval AB such that f of C is equals to 1 upon b minus c integration from a to b f of x dx. Okay. See here, students, since f is continuous, so there exists C belongs to open interval, that image of that point is 1 upon b minus a into integration from a to b f of x dx. Therefore, integration from a to b f of x dx is nothing but f of c into b minus a. Hence, proof of theorem is completed. Okay. Now we will see second mean value theorem. Second mean value theorem for integrals. Theorem is if f and g are continuous on closed interval AB and if g of t is greater than or equal to 0, a is less than or equal to t is less than or equal to b, then there exists C belongs to open interval AB such that integration from a to b f of x into g of x dx is equals to f of c into integration from a to b g of x dx. Okay, this is the second mean value theorem for integral. Proof. Suppose F and G are continuous on closed interval AB. Therefore, F is Riemann integrable on closed interval AB and G is also Riemann integrable on closed interval AB. Okay. Since F is continuous on closed and bounded interval AB, so F attains its maximum value, say capital M, and F attains its minimum value, say small m. I will not write here in detail. So we have m is less than or equal to f of x is less than or equal to capital M. Okay, m is the maximum value, small m is the minimum value and capital M is the maximum value. Okay, since g of x is greater than or equal to 0, a is less than or equal to x is less than or equal to